Okay. Mm. Okay, look this. How much gas is produced at in 5 seconds? How much gas is produced in 5 seconds? This is the 0, 1, 2, 3, 4, 5. 5. This is the 5. It is the intersection. Look how much gas is produced. How much gas is produced the when 5 seconds? Okay, how much gas is produced when volume is when time is 5 seconds? This is the 5 second here. This is the 0, 1, 2, 3, 4, 5. 5 second volume is 5 cubic centimeter. So A 1A A1 A is 5 cubic centimeter. Okay, now question number B. What is B answer? B answer when 10 second, when 20 second, 20 second, when 20 second, what is the volume? Here is a 2 unit, correct? This is the 10, this 2 unit 1, 11, 2 unit 1, this is the 6 unit, that means 3, 10 and 3, 13. This is the 13, here is a 13. Look, when time is 20, volume is 13. Cubic centimeter. Sorry, this is 1 and 2. One, this is 1, this is 2. Okay, now B. Question number B. How many seconds does it take to produce 10 cubic centimeter? To produce 10 cubic centimeter, what is the time? This is the 10 cubic centimeter. What is the now time? 10 cubic centimeter. Time is look, how much time? No sound. Hello? Alistair, are you listening me? So what is their problem? Okay, I am increasing sound. Now what is the sound? Increases sound? Sound increases or decreases? तो आज your problem की. Sir, you still can't join. Sir, it isn't working. Sir, you still can't join. You still I still can't join. Okay. So Jarif, no sound. Okay, don't need to listen now. Don't need. Okay, this is the 13 cubic centimeter. Now when uh, time is 10 cube, how many second does it take produce? When 10 cubic centimeter produce, how many second? 10 minute 10 cubic centimeter. This is the 10 cubic centimeter. Here is the cubic centimeter volume. I the time. When time is when volume is time is volume is 10 cubic centimeter. What is the time? This is the intersection. Here is the intersection. Down this bottom. Down this bottom. This is the how much? 5 and 3. 13. 13 second. One is time is 13 second. Now 2. 2 2 is 1 cubic centimeter volume. How many second? When 15 cubic centimeter. When this is the 15 cubic centimeter, this is the 15 cubic centimeter volume is this is the 15 15 16 17. No, this is the 25 20 and 5 25 are here come. This is down. This is the intersection. This is the 15 cubic centimeter. Now what is the time? Bottom, look this to the bottom. This is the 25 26 27 27 second. 27 27 second. Okay, now question number C. What is the rate of the reaction? We know rate of the reaction equal to. Do you know what is the rate of reaction? Rate of reaction equal to 2 way we can write. We know rate of reaction equal to volume produced volume produced divided by time taken. Time taken. Okay, volume divided by time. Okay, what is the question number 1? What is the volume? The 5th second. What is the rate of the reaction during 5th second? 5th second means time 5. 5th second means time 5. 5th second means time 5. When the 5th second, this is the 5th second. This is the 5th second. 0 1 2 3 4 5. Now what is the volume? Volume is also 5. Volume also 5. This is the time 5. This is the intersection. Go to the volume. Volume also 5. So volume 5. Time is also 5. Question number 1 answer. 1. Volume is 5 cubic centimeter. Time kato? Time also 5 second. Time time also 5 seconds. What is the rate of reaction? 5 divided by 5. Rate of reaction equal to এটা আমি এখানে নিয়ে আসি. We know rate of reaction equal to volume divided by time. Now volume we have find volume 5 cubic centimeter and time is 5 seconds. So what is the rate of reaction? 1 divided by 1, that means 1 cubic centimeter per second. Okay, this is the first question. What is the time of the volume? Okay, now question number 2 is yourself. You solve question number 2 by yourself. Okay, what is the rate of reaction when the 10th second, when time is 10 second, what is the, you will find here from this graph you will find the volume. Then you write time is 10 second, volume you will find from the graph. Then you write this equation formula, then you will put value and cut marks. 2 is your homework. 2 you solve yourself. You will solve 2 by yourself. Okay, now I am going to next topics. Oh, factor affecting on rate of reaction. This is the factor affecting on rate of reaction. Temperature, one factor is temperature, pressure. A factor means some things which affect the rate of reaction, like change rate of reaction, increase or decrease rate of reaction. The factors are temperature, pressure, concentration, surface area, catalyst. Okay, temperature, when temperature increases rate of reaction increases, pressure increases, concentration solution, surface area solid, when surface area increases rate of reaction increases, catalyst. These are the 5 factors that affect the rate of reaction. Let's watch a video to see how factor effect on rate of reaction. Okay, I am show watch a video. I didn't attach here. Very bad. This, where is this video? I should, this is missing. My marker.
Before we can understand how these factors affect the rate, though, we need to cover the theory behind reactions, which is known as collision theory. This states that in order for particles to react, they have to collide with each other with sufficient energy, which we call the activation energy. And if they collide with a less energy than this, then nothing will happen. They'll just bounce apart together. So if we were to think about an entire reaction, which will involve tons of particles, then the rate at any particular point is going to depend on 2 main things. The most obvious is the amount of energy that the particles have. The more energy they have, the more energy they can transfer during the collision, and so the more likely they are to surpass that minimum activation energy. Another important thing is the frequency of the collisions, which just means how often the particles collide with each other. So even though not all collisions are successful, because the particles involved don't always reach activation energy, the more often they collide, the more successful collisions there will be overall. Now, whenever you think about how these four factors affect the rate of reaction, you always want to think in terms of how they affect the amount of energy that the particles have and the frequency of the collisions, as increasing either of these will increase the rate of reaction by increasing the number of successful collisions. Let's start with temperature. As the temperature of a reaction increases, the particles gain more energy, which means that they move faster. And because they're moving faster, they'll collide more frequently. They'll also collide with more energy each time, so are more likely to exceed the activation energy. So overall, there will be a higher rate of successful collisions, and thus a higher rate of reaction. Now, concentration and pressure are normally considered as a single factor, because they both refer to how many particles there are per unit of volume. It's just that concentration generally refers to solutions, and pressure refers to gases. When either of these is increased, it means that there will be more particles per unit of volume, which makes the collisions more frequent, and so increases the rate of reaction. Just like concentration and pressure, a higher surface area will also increase the rate of reaction. For example, if we wanted to react 3 grams of magnesium with an acid, we could use a solid block of magnesium, small chunks of magnesium, or powder. As all of these have the same mass and volume, the powdered form would have the highest surface area to volume ratio, and so have a much higher area over which collisions with the other reactants, in this case the acid, should take place, meaning that the frequency of the collisions would be higher, leading to a higher rate of reaction. The last factor that we need to cover is the presence of a catalyst. Catalysts are substances that speed up a reaction without being used up in the reaction themselves. So we don't include them in the reaction equation, as they're not reactants or products. To understand how they work, we can use a reaction profile, which shows the change in the chemical's energy during a reaction. Now, this distance between the reactant's energy level and the very top of the curve is the activation energy, which, remember, is the energy that the collisions have to have before they can react successfully. What a catalyst does is lowers this activation energy by providing an alternative reaction pathway. And this means that there will be a higher proportion of successful collisions. The word catalyst is actually a pretty broad term, and a whole range of different substances can act as catalysts in different situations. One of the most common sources of catalysts, though, are the transition metals, like cobalt and nickel. And if you do biology, you'll have come across them in the form of enzymes, which are just catalysts made by living organisms. Anyway, that's all for this video, so hope you enjoyed it, and we'll see you next time.
Okay, have you watched this video? So how many factors affect on the rate of reaction? Okay, the concentration, the effect of concentration. Concentration reaction can be made go faster or slower by changing the concentration of reactant. Look, this is the concentration, lower concentration. Number of particles is fewer. Here is the number of particles are more. Here is the less particles. Here is the more particles. There are lower particles, more particles. More particles means collision occur. More collision occur. More collision occur means more successful reaction occur. So reaction occur if the concentration collision occur more collisions, the reaction will be successful. So here number of particles is more. Number of particles is more when high concentration. Number of particles is more, so more collision, so more successful reaction. So we have understood a reaction goes faster when concentration of reactant is increased. Okay, this is less concentration, lower concentration, here a higher concentration. When concentration is increases, a more collision occurs, so reaction goes faster. A reaction goes faster when concentration is of the reactant is increased. So this reaction is the faster because higher concentration. Here is lower concentration, so this is the slower. Now effect of temperature on the rate of reaction. Okay, if the temperature is increased, particles can collide more frequently. Particles can collide more frequently, so the reaction occurs faster. When time is 20, to take the reaction between hydrochloric acid and magnesium, to take the reaction to complete 119 seconds. When temperature is increased, to complete the reaction time is required 76 seconds. When temperature is increased 30, time taken for the reaction to complete 60 seconds. When temperature is increased, time taken for reaction 39. When 40 temperature is increased, time, so reaction faster. When reaction temperature is increased, reaction become faster. Here when temperature is 20, time taken 119 seconds. When reaction temperature increase 40, time only 31 taken. So when temperature is increased, reaction become faster. Okay, now the effect of surface area. Surface area effect is the solid substance. When substance in many reaction, one of the reactant is solid, the rate of reaction increase when surface area of solid reactant is increased. Like this is the surface area, this is the solid substance. Surface area 1, 2, 3, 4 surface area. Here reactant, this is the reactant, solid reactant. Another reactant participate 1, 2, 3, 4, 5, 6, 7, 8 like. When surface area, this is one cut, then this is smaller, then surface area increase 1, 2, 3, 4, 5, 6, 7, 8. Here all 8 cubic 6 surface area. Surface area increases, so more reaction can occur. When surface area increase, now how many particles can participate here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here was only 8 particles can contact this solid substance. Here when surface area increases, when I cut surface area increases, so reaction become more surface area, so more collision occurs, surface area occurs, more reactant can participate in the reaction. The effect of catalyst. Catalyst is a substance that change the rate of reaction but remain chemically unchanged. Catalyst is a substance. Catalyst change the rate of reaction. Catalyst is a substance that change the rate of reaction but remains chemically unchanged. So catalyst is a substance that change the rate of reaction but itself remain unchanged. Like this is a catalyst is a how catalyst. Catalyst is a substance that increase the rate of chemical reaction without itself suffering any permanent chemical change. Okay, catalyst increase the rate of reaction. When this the reaction look.
Sir, I didn't understand.
Didn't understand. Okay, this catalyst like this is a substance that change the rate of reaction. Okay, catalyst is a one kind of substance. It changes the rate of reaction, but the catalyst remain unchanged. Itself remain unchanged. Like two particles is like hydrogen and nitrogen. Hydrogen gas and nitrogen gas. To produce ammonia to produce ammonia gas. To produce ammonia gas, this reaction is slower. If we use iron catalyst here, iron catalyst if you use, the reaction become faster. After this reaction, this iron will remain unchanged. So here iron is a catalyst. Catalyst is a substance. It's change the rate of the reaction, but itself remain unchanged. Okay. So catalyst is a substance that change the rate of reaction, but itself remain unchanged. How does catalyst work? Catalyst did the activation energy. Look, here is how much energy is required. Minimum energy is required to complete the reaction. This is time. This peak the activation energy. This the activation energy here. This is the activation energy. 2 activation energy. Look. Okay, this is the activation energy. Look, this is activation energy. Look, this area is the activation energy. Okay, energy required to complete the reaction. This is the without catalyst. This is the activation energy. When I use catalyst, activation energy become lower. Activation energy become lower. Activation energy become lower. Catalyst complete the reaction, lower the activation energy using alternative path. Okay, so if the activation energy like energy required, this is the energy required. Like this is a 5 kilojoule energy is required here for catalyst, or this is 7 kilojoule energy is required for without catalyst. So this activation energy is catalyst. When catalyst this is without catalyst. Without catalyst. So catalyst increase the rate of reaction, lowering the activation energy. Here without catalyst, more activation energy. So when low energy, we can in a lower energy using catalyst, rate become faster. Okay, so catalyst increase the this is the reaction path without catalyst. This is the activation energy. the reactant path with catalyst. This is the activation energy. So activation energy decreases. So effect of on activation energy, it is particulate in a chemical reaction by forming temporary bonds with the it is not for you. Okay, have you understood how? Okay, which one is faster reaction between mango repan and rust formation? Which one is faster reaction between mango repan and rust formation? Hello student, are you listening me? Mango repan, yes, good. Mango repan is first repan, okay?
Sir, I didn't attend the class.
Huh?
So, will you upload this in YouTube? If you will upload, then I can.
The effect of concentration. देखो, the reaction can be go faster or slower by changing the concentration of reactant. Like this, the concentration lower concentration number of particles is low, higher concentration particles is more. More particles mean more collision. More collision means successful collision. So reaction occur faster. Here is a particles is low, lower concentration. So reaction slower. A reaction goes faster when the concentration of reactant is increased. When concentration is increased, particles number increase, collision increase, so reaction become faster when concentration is increased of the reactant. When temperature is increased, temperature reaction become faster. Look, what? Look, this is the temperature increase, about 20 reaction time taken for the reaction to complete 119 seconds. When temperature increased, reaction taken less time, 76. When time increased, temperature increased 30 degrees Celsius, 30 degrees Celsius. Now reaction complete within 60 seconds. 60 seconds. 60 seconds is required to complete the reaction. When temperature increased 35, now reaction is need 39 seconds. When temperature 40, reaction need to complete 31 seconds. So we have understood, if the temperature increase, rate of the reaction increased. Reaction become faster. Okay, because collision become more collisions. What? Okay, effect of surface area. In many reaction of the reactant is solid. Is one of the reactant is solid. Surface area effect when reactant is solid. One of the reactant is solid. The rate of reaction increase when surface area of the solid reactant is increased. Like this is left hand side. This is the solid reactant. Here is another reactant. Reactant surface area 1, 2, 3. Here this surface area. So how many reactant can participate reaction? 1, 2, 3, 4, 5, 6, 7, 8. Now I cut this one. Particles, now surface area increases. If I this particle, big particles, one smaller, now surface area increases. Now more reactant can participate in the reaction. Here was 1, 2, 3, 4, 5, 6, 7, 8. Now when smaller size surface area increases, when I cut this big materials, surface area increases. Now more reactant can participate. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, even 12, 13, 14. Now more particles can participate in the reaction. So surface area increases, rate of reaction increases. Like a particle is solid particles now if I becomes powder, solid particles turn into powders. The surface area increases, the rate of the reaction increases. Catalyst is a substance that changes the rate of the reaction but remains chemically okay. Catalyst is a आदि भाई এখন জয়েন করে okay. Catalyst is a substance that changes the rate of a reaction but remain chemically unchanged. Chemical transition metals are catalysts. Catalyst is a substance that change the rate of a reaction but remain chemically unchanged. I have shown these things. This reaction, for this reaction when hydrogen and nitrogen react to form ammonia. In this reaction is a formation of ammonia formation. This reaction required more times. If I use catalyst iron catalyst here, iron catalyst used in this reaction, the reaction become faster. So iron is a catalyst, is change the rate of the reaction. After the reaction, the iron remain unchanged. It don't participate in the reaction. Iron don't participate in the reaction, but it increase the rate of the reaction. Okay, so we have understood catalyst is a substance that change the rate of the reaction without itself remain unchanged, but okay. How catalyst work? How catalyst change the rate of reaction? Reactant, potential energy. How catalyst work? Reaction coordinate, reaction path, this is the potential energy, yeah. Okay, like a reaction is occur when there is no catalyst, like reactant, when there is no catalyst, when no catalyst, this is the energy, this is the activation energy, more activation energy required when catalyst when catalyst is used. No, without catalyst, there is no catalyst. Without catalyst. Okay, this is the activation energy without catalyst. This is the activation energy. If I use catalyst, activation energy become lower, then reaction product form. So now activation energy is here. Activation energy is now lower when catalyst is used. When catalyst is used, activation energy becomes lower. Catalyst. So catalyst lower the activation energy, change the reaction become faster. In a few energies, reaction becomes faster. When without catalyst, so catalyst increase the rate of reaction, lowering the activation energy. So in a few less energy, reaction becomes occurs with catalyst. Without catalyst, reaction need more energy. So we have understood catalyst increase the rate of the reactions using alternative path. Okay, everyone, switch mute. Now we'll give answer some question. Okay, which one faster reaction between mango ripening and rust formation? Mango ripen, fast reaction. Okay, fast rust formation need at least 1 year. 1 year, 2 years. Mango ripen 1 month. No, the 2 month. This from mango ripen is like okay. This is the faster reaction. The rust formation is slow. Okay, if 40 cubic centimeter of hydrogen gas is produced is 5 minutes. Calculate the rate of the reaction. What is the rate of the reaction?
8.
Yes, 8. Okay, rate of the reaction equal to volume.
40 divided by 5.
Yes, rate of the reaction equal to volume divided by time. Volume divided by time. Volume is 40. Volume is 40. Time is 5. 40 divided by 5, that means 8. 8 cubic centimeter per minute. Okay, now next question. What are the factors affecting on rate of the reaction? What are the factors
Concentration.
Tajwar, stop talking. Tajwar, what are the factors affecting on rate of reaction? Near Tajwar kids. Okay, what are the factors affecting on rate of reaction? Temperature, okay. Concentration, তারপরে একদম শেষে কি পড়েছিলাম? সি দিয়ে নাম সি সি এ কে টা ইয়েস ক্যাটালিস্ট, আরেকটা কি সারফেস এরিয়া, আরেকটা কি সারফেস এরিয়া, টেম্পারেচার, প্রেসার, concentration, surface area, catalyst. 5 factors. Okay, thank you for joining the class. Okay, I'll give assignment. I didn't prepare yet. I'll post in the Google Classroom. Okay, assignment. Wait. Okay, thank you for joining the class.